Our next topic in our quadratic functions is transformations of a quadratic. We have already worked in vertex form. We have graphed it and we've identified the characteristics from it. But now we want to know what each part is really doing to the graph of my quadratic function. As you read through this paragraph, note some key things. There is always a parent function to a graph. The parent function of a quadratic is x squared. So if you want to write it so it's a little bit more visible, your parent function is x squared. That is the basis of our quadratic function. Everything else is a transformation. Everything else is transforming this parent function. So let's talk about the different types of transformations. The first type that we have is a vertical shift. Okay. Vertical means we are going up and down. The notation that we see, it's going to be the k value of our vertex form. If I have a positive k, I'm moving up. If I have a negative k value, my function is moving down. Remember that this k value is also the minimum of your quadratic function. So this is the y value of your vertex, which means it's always the y value of your minimum or maximum. A horizontal shift is something that's moving our function to the left and to the right. Our horizontal shift is represented with the letter h in our vertex formula. Now we have to look carefully at this part of our formula. It is represented as x minus h in our vertex formula. This subtraction sign is always a subtraction sign. So, if I choose a positive h value, we're going to do the opposite. This is really moving left. And if I have a negative h value, this is really moving right. Now, if I were to show you this algebraically, it looks a little something like this. Okay, I have x minus a positive number. That is still a subtraction sign. That subtraction sign is to the left of my graph. Now, if I were to do x minus a negative number, we know that minus a negative is really positive. That's why we're moving to the right. Our next transformation is a reflection over the x-axis. The reflection over the x-axis is a negative. All I can look for is a negative out front. So really, what it looks like is a negative a value, but the negative is the only piece that is telling me that I have a reflection. Okay. The change to my graph is it flips. My function should now look like that. A vertical stretch or shrink is represented by the A value. If I have a positive A value, okay, that's greater than 0, or excuse me, a positive A value that is greater than 1, let's fix that. If it's bigger than 1, I have a stretch. If I'm looking at my positive A value, it must be less than 1 to be a shrink. But when I say less than 1, I am talking about fractions less than 1. Because we just learned that the negative means a reflection. The negative is not a vertical stretch or shrink. The vertical stretch or shrink is the A value. Bigger than 1 is a stretch. Smaller than 1, talking about fractions, is my shrink. So let's talk about some examples that we could come across. Flip your page over